Welcome to my output for Advanced Chemistry, which is a course requirement, Creating a Model. My name is Marilu Espinita, and this is for Dr. Regime A. Albor. Research shows that the use of technical aids and instructional materials helps students learn faster and make the actual teaching job easier and time-saving. Because of lack of facilities, lack of science, and other problems, it is best to do improvisation of science teaching materials. Pictured here is an improvised electrical conductivity apparatus, which we can use to address the following learning competencies. Number 1, recognize the different types of compounds, ionic or covalent, and also describe some properties of metals and nonmetals, like electrical conductivity property. For the first step in constructing the device, we will gather all the needed materials. We have 1 meter copper wire with plug, 15 watts bulb, 1 receptacle, nails, 1 bulb holder, 2 keys, and 2 holder slide. Number 2, connect the 2 pieces of stainless steel to the 30 cm copper wire. Wrap an electrical tape to the electrode. Number 3, cut the mini B plug end of the USB cable. 4, screw the bulb to the receptacle. Cut 15 cm of copper from the 45 cm copper wire. Screw one end of the electrodes to the receptacle as shown. Connect one end of the USB cable to the 15 cm copper wire as shown. Connect the other end of the USB cable to the free end of the 30 cm copper wire with electrodes. Your setup should look like the figure on the left. For the last part, let's construct the body out of plywood or any available materials for your electrical conductivity apparatus. The body may be constructed like the one below.
Hello everyone, I'm proud to present to you our school's improvised electrical conductivity apparatus. I have been using this since 2018. This is our product after I joined a contest on improvised instructional material. So here, we are going to test and compare the electrical conductivity of covalent, bond compound, and ionic compounds. So here you can see our setup. We have candle wax and sugar, which are both covalent compounds, and benzene or monosodium glutamate, and sodium chloride or the table salt, which are both ionic compounds. We will test them in solid form if they can conduct electricity, and also in liquid form. We are going to mix them later with distilled water. So let's check first the functionality of our improvised apparatus by testing with distilled water and tap water. Remember, if the bulb lights up, it means the compound can conduct electricity, and if it does not, the compound cannot conduct electricity. Let's try it out with distilled water. Do not touch the ends of electrodes during testing. Okay, look at the bulb. There is no light produced. And then the other one, which is tap water. Okay, you can see the light on the bulb, meaning tap water can conduct electricity. So we may tell our students the reason why. Okay, first, distilled water is currently made of the bond between 1 hydrogen atom and 2 oxygen atoms, which are both non-metals. The other one, okay, the tap water, which come from the spring or water from the river, and most especially the ocean water, they have mixed minerals from the rocks. The tap water, spring or river, the water flows in the river where there are rocks. Therefore, minerals from the rocks mixed with the water, making it a very good conductor of electricity. You see? And that is why during the synthesis or application of the lesson, we can tell our students that it is very dangerous to move around fluid water, okay, during heavy rain because of the danger of electrocution. Okay, so here, let's try it out with now the covalent bond and the ionic bond. And take note that covalent bonds are elements of non-metals, okay, like candle wax and sugar, while ionic bonds are elements of a metal and a non-metal. Alright, let's test out the covalent bond compounds. In solid form, okay, you can see there is no water, purely candle wax. Okay, look at the bulb, there is no light produced. How about the sugar? Still, no light is produced on the bulb. This time, let's mix them with the distilled water. Okay, so we are comparing in solid form and in liquid form. Okay, let's mix with these. Make sure you are not using both ends so to avoid contamination of your compounds. So let's check it out first with the candle box. So even in solid form, it's not a good conductor of electricity. While sugar, it's a poor conductor of electricity. Look at that one. So also, covalent bonds are divided into the non-polar and the polar covalent. Yeah. So this is a polar covalent bond sugar. So they are polar conductor of electricity. While the candle wax are non-polar and they never conduct electricity. This time, let's proceed with the ionic bonds. Let's try out now the ionic compounds in solid form. Make sure that there is no wet sample here. Okay, you can see there is no light produced even in solid form. After the steam, clear out to avoid contamination. Next, let's do the sodium chloride or the table soup. Alright, there is no conductivity. So the next part of the activity comparing is to compare them in aqueous form or in liquid form. And begin with okay, in liquid form, the benzene is a very good conductor of an electricity. It's an ionic compound. Then let's try the table salt, very good conductor of electricity. And then you may ask the students as to why. So that's how you use the improvised electrical conductivity apparatus. Before we made this, it was really hard in comparing ionic bond and covalent bond until we were able to construct this device. That is all. Thank you very much for watching.